All right, good morning, good evening, good afternoon, and welcome. So this is lesson 3.6. We did this lesson right before Thanksgiving break. This was supposed to be done with our linear equations, but we kind of pushed it to the side and wanted to do it later on in the year. So this is the one we did before Thanksgiving. It was about the arithmetic sequences as linear functions, okay? We still have topics due on ALEKS. Please make sure you do that. The homework is actually still located up. If you're watching this the week of Thanksgiving, then ladies and gentlemen, you have until Sunday. And because I posted this video late, if I need to extend it a day or two, I can do that. But please make sure you're fully aware of what's going on. Here's the essential question. If you don't have the notes, go to Canvas, print them out. They're already there up and loaded. All right, so we didn't have any bell work. We kind of skipped it. We're going to talk about repeating expressions, okay, in a linear function, recognizing the sequence, and relate the arithmetic sequence to a linear function. All right, so let's begin. Vocabulary, sequence, terms, arithmetic, or I like to call it arithmetic sequence, and common difference. Common difference is a huge one for us in this example, okay? It's going to be kind of understanding and writing an equation like we did earlier with y equals mx plus b. So here's the big thing about arithmetic sequence, okay, is the change in rate, okay? So if it's constantly increasing or decreasing from the first sequence. So this is A1, or the first sequence number, to the second, third, fourth, fifth, up plus 2 every time. This one is going down, minus 4 every time, so that's why D equals. So on our notes, we want to make sure we do that. All right, determine whether this is an arithmetic function. Go from here to here to here. Every time you go down, it would be -2. So it's going to be D equals -2. It's important to get that understanding right now for the common difference, because as we move forward, you guys will see the main key factor. Is this a function? So if I go here to here to here, this is -2, 4, and then 6. So this is not an arithmetic sequence. All right, not a sequence. Do these two. All right, look at them real quick. Make sure what's the change from here to here to here. D equals -4, okay? Actually, it's not negative. It's going to be positive. I forgot about that. It's not negative. That's going up in numbers, so don't do what I did. D equals 4. And then this one over here, ladies and gentlemen, this is 3, 5, 26. This is none. Okay, not a sequence. So we know on this one, D equals 4. Simple setup. Now, what are the next 3 terms in the arithmetic sequence? So first you need to find out what your D, your common difference is. -8 to -11 would be -3. Okay, so I know my D equals -3. Now what are the next 3 terms? It'd be -20, 23, and -26. Okay, you're just adding -3 into it. Now, on the homework, you guys will get some questions like this, so please make sure you understand those completely. Okay, next on, ladies and gentlemen, is you do this one on your own, please. All right, on this one, find the next 4 terms of the sequence. So this sequence would be 1.5 as the change. Now what you need to do is, so if D equals 1.5, my next term here is going to be 15.5, 17. Please make sure you have that correct. All right, next. So that's a sequence. Now, the nth term. What an nth term is as I explained in class, it's kind of like if you have a bag full of marbles. On your notes, there's an example of a newspaper, okay? But what you need to understand, or else instead of the marbles, it'll be like a pallet of water, because, you know, I've been drinking a lot of water lately. And when I pick up the bottles of water, ladies and gentlemen, they come in a 40 pack. Okay, that 40 pack probably weighs about 30 pounds. Out of all those packs, okay, all the weight needs to be exact. They should be exactly the same. So how you would figure out is if you had like a forklift that you were trying to lift up, and the forklift could only lift maybe 5,000 pounds. When you start to lift it up, you can't overstack the water, right? So what you're doing is that when you have one, you add one thing in a bottle of water, it's 30 pounds. Add another, that's 60, 90, 120. You get the gist, right? It's a numerical sequence. But we have a starting point. Okay, so if we have a starting point, because we're not starting at 0, you actually are going to put usually the water on a wood pallet. The wood pallet weighs something, so you got to figure that weight out, and then from that starting point, you would go from there. So that's kind of what we're doing here. Okay, if you guys, what we're trying to do is we're finding a sequence. Okay, we're starting with the very beginning number. When we did y equals mx plus b, if you guys remember on that, we would change. So let me put my pen back in here. We did y equals, change colors. All right, we did y equals mx plus b. Okay, we only had two variables that we changed. We would always change the b and the m. But the y and x were there and we never changed them. This is the same philosophy with this equation right here. Okay, to find the common difference, you have to write this equation out. The only thing that changes is this a and that d. Everything else is written the same. So when you start writing this equation out, you start it with a to the nth term. And what this means is once we create this equation, we can figure out in a line of sequence like 50 or 60 or 45 down the road, you can find out what a to the 45th is, and we can count down, and it'll give us the number without us adding 3, 6, 7. Hopefully you guys make sense, and if it doesn't, you guys will get the gist in a second. So here we go. Write these equations in nth form. So first we need to start out by finding the d, and we need to find out the a1. Okay? So both of these. Now our a1 is given. It's right here. It's the first number in the sequence, which is 1. All right, and then what is the d? Functionality for moving here to here is actually going to be 9. So now that we know that, we can write our equation. So it's a9 equals, remember here's the equation. All right, and it's times d. So what can we drop down? Well, we know right away, okay, we can drop down the an equals, we know we can drop the plus and minus 1. Now what is the a1? In this case, ladies and gentlemen, so I'm going to change the color again. It is 1, so that would drop down. What is the d? Times 9. Now, next step would be to distribute. Distribute this into here and that into there. So you would have an equals 1 plus 9n minus 9. Then you combine like terms. So lastly on this, these would come down. So what is negative 9 plus 1? Final equation would be n9 minus 8. So there's your equation, okay? So what I want to make sure you guys know is so in this sequential line, okay, this is our equation that helps us find any number value. If you were to test it, if I put in an a2 here, okay, if I put in a 2 in here, the 2 goes into here, so it'd be 9 times 2, which would be 18. 18 minus 8 is what? 10. All right, so let's talk about it. This is what I mean. We're going to find the 12th term. So here's a to the 12th. So we're taking our original equation. What is the difference between this equation, sorry, that's a horrible looking n, and this equation? Well, I took the n out and I replaced it with the 12. So you got to do the same thing with this one. So it's going to be 9, instead of putting n down, times 12 minus 8. Then you got to use PEMDAS. Okay? So 9 times 12 is 108 minus 8. A to the 12 equals 100. So there's your answer. So if I were to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th sequence down will be the number 100. All right, so now you want to graph the terms. So on graphing, it's kind of graphing the dots. So what I mean by that is that here is, you have to think of this as, if this is a to the 1, so if this is the first number, okay, technically we could rewrite this equation and we could graph it to a 9x minus 8 equals. So if we're going to replace the n with an x, over here the only other variable we need would be to create a linear equation would be y. Okay, so if can you graph this equation now? The answer would be what? Yes. But if I plug in a number here, so if I plug in the number 1, which would be the same as this one up here, all right, my point would be 1. 9 minus 8 is what? There's my first point. If I plugged in a 2, if I plugged in a 2 here, it'd be 9 times 2 minus 8. So 9 times 2 is 18 minus 8. My point would be what? 10. If you guys notice, if I did a 3, okay, it'd be 27 minus 8, which would be 19. Look at the difference. Look what's going on here. 1, the first sequence. 2 is the second sequence, and the y is 10. 3 is the third sequence, and it's 19. You guys should hopefully get the drift by now. Okay? I'm not going to write the fifth sequence out. You guys can figure it out. Know when you plot this out, you could technically create a linear equation so steep that every time you hit a value of 1, 2, 3, 4, you could trace on decimals on the x value, and it would give you the y value, so you'd be able to plot a point. Okay, now the only thing I want to know is, here's the last piece. And what does is always mean in an equation? Okay, if you guys remember, is in an equation always means equal. So if it's equal, we know 172 is equal, but what is it equal to? Well, it's equal to the original equation. And then on this one, ladies and gentlemen, you would just, of course, solve for n. So plus 8, do your setup, 180, 9n, divide by 9, n equals 20. So on the 20th number, on the number line sequence, the 20th term equals 172. All right, your guys' turn. Okay, on this one, ladies and gentlemen, write an arithmetic sequence. My D is subtracting 13. My A1 is 3. Now you can write your equation. So it would be AN equals, and then it's 3 plus n minus 1, because that doesn't change, times a negative 13. Then you do your math. So I'm just going to go 3 plus, but actually what it's going to be is, not 3 plus, because it's going to be 3, and then negative 13 times n is actually minus 13n. Negative and negative is a positive. Now you combine like terms, and it's going to equal a, so here's your equation. All right, so now we have our equation. Can we find everything else from there? Yes, we can. In a calculator, what I want you to do is to find the 15th term. So a to the 15 equals negative 13 times 15 plus 16. You multiply that out, I believe you get 195. And then you add that together, you would get negative 174. Yep, I think that's right. Hold on. 80, 90, nope, 74, 79. Oh, jeez. Negative 179. All right, there we go. So a to the 15th number in this sequence here would be negative 179. Same setup, minus 114 equals negative 13n plus 16. So now you do that simple math to find out the letter D part. Oh, you can't see that. Let's go this. All right, it'd be minus 16, do your math setup, negative 130, negative 13n, divide by negative 13, ladies and gentlemen, you get n equals 10. All right, so the 10th number in the sequence is 114. All right, so what you could use this for, ladies and gentlemen, is if you guys want to find out how much money you'll make at any time in your life, if you're trying to sell a bunch of product, you have a starting value, and then you could figure out, if you knew the equation, you could plug in any number at any time and type it in the calculator, and you would know your dollar amount. Okay, so here's the other setup on these sequences. I just want to make sure you guys can do this. Here's a real world example. All right, my D equals 11. My A1 is 12. You would write out your equation, a to the n equals, and then it'll be 12 plus n minus 1 times 11. Distribute properly. Okay, when you distribute, you get a to the n equals 12 plus 11n minus 11. And then the last piece of the puzzle will be to combine like terms. 12 minus 11. So my equation is 11n plus 1. That's your function. Okay, do I want you to do anything else at this point? No, I know there's a letter B to it, but I'm not really concerned with that right now. And so that is your answer. So make sure you guys know that on this equation I can know how much a bag weighs for each additional newspaper that is added. Okay, what I want you guys to do is graph the function. Remember, in order to graph it, you change this down to a y equals 11x plus 1. And then you could determine the domain, okay? The domain and the range. So on this calculation, ladies and gentlemen, if I knew my domain started at 12, okay, if I graph this function, ladies and gentlemen, my domain and range is all real numbers. But the reality of this word problem would technically be that you would start at 12. So my domain would be 12 is less than x, which is greater than or to infinity. Okay, so that is my domain. Now, if you do graph this though, you would, if you were to graph this function, the domain and range would be all real numbers. However, what I want to do is I'll make sure before we take a major assessment, if I do have domain and range on there with you, that I will cover it. Okay, make sure that I tell you the answer as we go through. All right, so there's the domain, that's great. Woo! The domain would be 0, 1, 2, 3, 4, all that good stuff. All right, so what they have is the following, ladies and gentlemen. This will be the last piece of the puzzle. Okay, use the knowledge that we have. Okay, the D on this one equals 1.5, and then your A1 is 8. You should be able to write the graph at that point and go from there. If you have any questions on arithmetic sequences, okay, please come find me or ask me. ALEKS has a really great tool within the homework. Look at the worked out examples as you guys go through it. Questions like 1 and 2 are the similar, 3 and 4 are similar, 5 and 6. So I kind of did that this time to change up some of the perceptions to get you guys more challenged. If you have any questions, please come find me, okay? This is the only, we're not going to test on this. This will be shown on your final, and then this will also be on the Galileo AZ Merit that we're going to be taking after spring break as well. So I'll make sure to cover it again, but just remember if you're looking at an arithmetic sequence, what it is. It's adding the same rate of change on the numbers, okay? Like we were doing plus 3, plus 3, plus 3, or minus 4, minus 4, minus 4. That is an arithmetic rate of change or a sequence. Ladies and gentlemen, if you see this before Thanksgiving, happy Thanksgiving. Otherwise, if it's after that, I hope you had a great time with family and friends, and I will see you in school shortly.